Mark,
All
you
right.
there?
Yeah, I'm good.
All right, we're recording. So this is our SQL injection project for CSE 45302 for week 6. So just going to go over the code real quick. We started off. We have we ask the user for 2 inputs, a username and a password, and then we first show what the form the attack might take before performing weak and strong mitigation strategies. The weak mitigation strategy, which begins right here, simply goes through and looks for any SQL terms that it deems to be in any way compromising to the password or to the program, and it takes them out. And then it goes through and removes any special characters that also might get in the way. That is our weak strategy. And we'll demonstrate all this at the end. Now the filtering of the text is also case independent, meaning that this function here will take the text whether select is written with a lowercase l, lowercase e, whatever, takes it in here and ignores case to substitute it for nothing. So that's an important little detail. The next step for the strong mitigation is to look through a series of blacklisted terms, and should it find any of those, it removes all forms of code from the program. And that happens because SQL relies on white spaces between the terms. And so at the presence of a white space, everything afterwards is removed and the code is sent back without anything after that first section. So it also identifies the likely type of attack that is being presented to the user, and then presents it back to the user. And so here we have just a return of just the first component of the array. So it converts it into array because the password will be its own, be the first segment of the array, and then all the rest of the SQL will follow. So that's our strong mitigation strategy. We also check the user list to determine whether the user exists in our database. Obviously, we don't have a database set up right now, and so we have a associative array where we have a series of users and passwords, which ordinarily would be hashed, and there would be some kind of unhashing of passwords in order to determine the password validity. But for the sake of this this lab, we decided to leave it as just plain text. So our user object has 3 users, and test was obviously the most common one, as you'll see in our test cases. And so it will attempt to locate the user passed in, and if it does, it attempts to match the password entered with the password that is in the field. If it determines that to be a match, it tells you so. If not, it doesn't. So that happens in this part here. So if check user list is successful, it prints a statement telling you that that user has been verified. Otherwise, it tells you to to enter a valid username and password. And lastly, we present a SQL statement, which is a very likely output for the SQL program to determine whether a user and password were correct, and so that is presented to the user. And we present that a couple of times. We present it for before the mitigation strategies are done, and then after as well. So without any further ado, we're each individually going to run 2 test cases, and we'll explain them as we go. So I'll start off, since I've got the helm. I'm going to first put in test as our user, and then I'm going to put in the first attack, which is a union attack. Let me attempt to copy that again. I'm sorry. So if I press return on that and paste as plain text, there is my union attack. And if I was to press return, you'll see, and I'm going to bring this up a little bit. The SQL attack is here. Select star from users where user equals test and pass equals test. Select authenticate from password list where root and password equals nothing. Union select authenticate from password list And so there's our union statement at the end there. So we have a weak mitigation strategy where it asks, obviously our username is incorrect because this had a lot of text, for example, that was not filtered out. And so the program assumed that was part of the password. And so that was incorrect. And then the strong mitigation method, it was able to remove everything that was not intended to be there. So from here, it started here and removed everything that was after. Keeping that, obviously, that's a different type of quotation which should be filtered out. So that's user error on that part. So I could quite easily add that, for example, up here, and we could filter that out without any trouble. In fact, I'm going to do that real quick just to show you what that does. Equals. So it's a different type of quotation and then replaces it with nothing. So if I run that code again and copy my code again, so let's do that, test, and then paste as plain text. We have the exact same thing because I copied over some extra things. I copied over a return, that's why. There we go. So that didn't change it. So I probably have the wrong quote. I don't have the wrong quotation. There is no quotations in there. It just treats this as one long string instead of being what it's supposed to be. So it didn't work here. So enter a valid username and password. Whereas in this part, it's been verified because the wrong part of the code was removed. So that's that one. The other one is, I did them in reverse order, is an additional statement attack, which I'm going to demonstrate now. So if I hit run on this, we can do user. There is no user in our system, so that's going to return invalid. But so here's our attack up here, and that's before it's obviously been filtered out. Our weak mitigation strategy is as shown here. Select from user where user and pass equals this. So there's the valid username and password. So you can see that all of the text has been filtered out. That was not a SQL statement. And then we have our strong mitigation strategy, which resorts it back to what it's supposed to be, which is user and pass. And so those are my two. Mark, I believe you're up next in our order.
Yep. So for mine, I've also got a union, or excuse me, an additional statement example. So we'll enter the user of test again and copy my statement here.
I think you copied one.
We'll see that go in, and you can see, what was that?
Oh, never mind.
Okay. So you can see that that goes in and that it wasn't accepted. And same thing, you've got a string that's come in here, and then for the weak mitigation, and then for the strong mitigation, we've got additional statement attack, and then with the cleaned up SQL statement. So, and then for my second example, I've got a tautology example. So username will be test, and our Google Doc is scrolling on me. So, and then here you can see that we've got the or statement and the x equals x example. And once again, the weak mitigation demonstrates that it turns that password into a long string. And then the cleaned up strong mitigation is assuming that select is the attempted password. So, and those are my two examples.
Cool. So my two examples here. So my first one, I try an additional attack statement test as the username. And oops, lost it there in the Google Doc. There we go. Here's the additional attack, and it's also going to always ring true for P equals P. We can see in the weak mitigation here that it's an invalid statement, and whereas strong mitigation, we've been able to actually remove it. In the second test example, sorry, I think I pulled up. Oh, okay, yeah. Okay, so this one we'll use test again, and instead we're going to try to pull from the username list using an additional attack statement again. And then we can see that we've removed the attack and the strong, and then in the weak that is didn't go through. So there's that.
Thank you. And there's one other test we did not demonstrate, which was not one of our test cases, but worth demonstrating. And that is the mixed case test. So for example, if we had test as our user, and then for the password, we had test, and then had select even lowercase, star from users. I'm just going to do that. Then this should take out all of those things. And as we can see here, it did. We can see right there that there's our username and there's our password, so that it was able to demonstrate, it was able to find in both cases that the different cases were not a problem for the program to detect. But that's, I believe, everything that we had to demonstrate in this. Was there anything else that you guys wanted to demonstrate or discuss?
No.
I mean, it doesn't cover everything, but it does cover a lot of things, right?
Right.
So it's good.
All right. Well, thank you for watching, and that's it for us. See ya.
See ya.